Welcome to implementing Azure Site Recovery for on-premises to Azure DR. And well, I hope you're all enjoying Ignite so far. I definitely enjoyed the keynotes yesterday, and I'm looking forward to attending a couple of sessions this afternoon. But I know how hard it can be to choose the sessions you go and see, so I really appreciate you coming to this session this morning. So who am I? My name's Daniel Bobias. I'm the Innovation Lead for Datacom's cloud teams down in Wellington, and I also help run the Microsoft Infrastructure and Azure user group down in Wellington as well. So if you're interested in learning more about Azure and you enjoy beer and pizzas, then please join our meetup, and we'd love to see you at the next session that we're holding. I want to cover three things in the session today. I want to talk about what Azure Site Recovery is and why we should be interested in it. I want to go over the planning and the checks that we need to undertake when we're looking at or considering using Azure Site Recovery. And then actually, how do we go about implementing Azure Site Recovery? And more importantly, failing over to and back from Azure. So we've got quite a bit to cover in an hour. But first, I want to tell you why Azure Site Recovery caught my eye. Now, a number of years ago, longer than I care to count, I was 20 at the time, I was IT manager for a small digital startup called 4RF Communication. Some of you might be able to guess by the name. 4RF designs and manufactures digital microwave radios. Now, like many startups and 20-year-olds, we had really grand plans and big ideas about what we wanted to do, especially what I wanted to do around DR. But like many startups and 20-year-olds, money was pretty tight. We launched just before the bottom fell out of the tech market. So there wasn't a whole heap of money to go around. So while I had all these big plans about DR and sites and replication, actually, the reality is all I could afford was one of these. A red folder with all of my DR instructions in it, the contact details for my suppliers, how to rebuild my servers, and how to recover my data off my backup tape. And that used to sit there on my bookshelf at home. I never had to use all of it, only little parts of my DR plan. To this day, I'm not really too sure whether my DR strategy would have actually worked or not. Now, if Azure had been around back then, and ASR had been available, well, I think things would have been quite different. So ASR, it's not only really easy to DR our servers up to Azure, it's also incredibly cost effective as well. We only pay for the storage that our servers consume in Azure, and we pay a fixed cost per VM for the ASR service. Now that used to be 18 New Zealand dollars per month per VM. 3 weeks ago now, Microsoft dropped that cost all the way down to 37 New Zealand dollars per VM per month. So it's a massive price reduction that Microsoft have just announced, which makes it even more cost effective. We only pay for the running costs of our virtual machines when we actually fail over to Azure. So what does ASR do? Well, it allows us to replicate our virtual machines and our physical servers up to Azure. We can then use ASR to orchestrate our fail over to Azure in a DR situation. And it has some really handy features that allow us to do DR drills, to be able to test our failover without impacting our production systems and the replication we've got in place. And finally, and I really like this feature, we can store multiple recovery points in Azure, which means when we fail over, if we bring up our virtual machines in Azure and we go, ooh, it's not quite the way I need it to be, especially if I've made a manual change to a virtual machine, administrator misadventure, which has caused me to fail over, I can roll that virtual machine back to a previous recovery point prior to the time that I made that change. So that's really helpful. Okay, so we can use ASR to protect our virtual machines which are running on Hyper-V hosts which are managed by System Center Virtual Machine Manager. We can also protect virtual machines which are running on standalone Hyper-V hosts. And we can protect virtual machines which are running on VMware infrastructure and physical hosts as well. Now, I'm not going to cover it in this session, but Azure Site Recovery can be used to protect virtual machines between our on-premises sites, either Hyper-V to Hyper-V or VMware to VMware. And Microsoft have announced a new scenario which they're working on at the moment. And they announced it at Ignite Atlanta a couple of weeks ago, where shortly we'll be able to protect virtual machines between two Azure regions. I think this is really cool because it means we can bring our workloads up to Azure, and even those single instance workloads that don't necessarily get the SLAs, and then we can use ASR to protect those workloads to a different Azure region. So I'm really looking forward to when that functionality becomes available in preview, and we can actually have a test and a play with it. Okay, so for the demos that we're going to be doing today, I've a number of workloads running on a Hyper-V host in a very similar configuration to what we might find in a branch office. All right, my garage is not quite as salubrious as a branch office, but I think we're going to sort of get the gist. It's going to be a bit like a cooking show. We're going to check back in on things as they're working along. So we're going to jump onto my branch office server. We're going to have a quick look at Hyper-V and how ASR integrates with that. And then we're going to kick off a planned failover, because I've got some maintenance occurring at home, and I want to get my virtual machine up to Azure before then. So if I get the right button, 8, there we go, and I cut across. So this is my Hyper-V host running in my branch office. And the first thing we'll see here is under my replication tab down the bottom, we're getting information about the replication that I've got enabled. So I can see here that my replication health is normal, that my replica server is Azure, and I can actually click in and I can get more information about that health. So right within my Hyper-V console, I'm seeing the status of my virtual machines and how they're being replicated. I can see how many successful cycles I've had, and actually the amount of data that I'm replicating between each delta replication. To make this a bit real, and to put a bit of pressure on myself, I've got my virtual machine here. I thought we'd create a file on the desktop. Let's call it Ignite and some random number. And then when we fail that virtual machine over, we're going to check to make sure that that file's still there so we can show we've had no data loss. So we're going to pop across, and we've got test VM2. We're going to click off a planned failover. I'm going to take you through the console a little bit later, but I want to get this underway. So we're going to click OK. Now this is going to start a planned failover. If I click in here, okay, there are a number of steps that it's going to go through. So we're going to come and check back on that shortly. All right. So what are the moving parts when it comes to Azure Site Recovery? Well, obviously we need to have an Azure subscription. And inside that, we need to have a Recovery Services Vault. Our Recovery Services Vault stores our Azure backup information and our Azure Site Recovery information. We also need to have a storage account to store our DR data into. And we need to have an Azure Automation account. We'll talk about that towards the end of the session. Okay? And we need a VNet, so our virtual machines can communicate when we fail them over to Azure. Now, the software we deploy on premises is going to depend on the virtual host and the virtual infrastructure that we've got. But in general, we're going to have some form of agent, which is going to be installed onto our virtual hosts. And if we're running VMware, we're going to have a virtual configuration server that we need to run on our infrastructure as well. Now, on our guests, there's no ASR agents that we need to install on our guests, but we need to install the Azure VM agent onto our guest virtual machines. There's two reasons we need to do that. When we fail the virtual machine over to Azure, if the VM agent's installed, then our virtual machine starts up about 3 times more quickly, so we get there faster. But more importantly, if our Azure VM agent's installed, we can communicate with our virtual machine via the Azure control plane. And when we fail this virtual machine over, I'm going to show you why that's really important that we have that functionality available, because we can reconfigure our virtual machine using that control plane. Now, those of you that have looked at ASR in the past, and there are just 1 or 2 of you here, you might be saying, yeah, but Dan, where's the master target server and the config server running in Azure? So Microsoft made some changes last year, and we no longer have to worry about those servers. They're deployed automatically, they're hidden from us, they're in a different subscription, we don't see them, we don't manage them, we don't worry about them anymore. So Microsoft have made it far simpler for us. The only other virtual server we need to be aware of, and again, it depends on the scenario, and it's generally the VMware scenario or physical hosts, we may need to have an on-premises master target server that helps us with our fail-back scenarios. All right, so we've got an idea of the components now. What are the requirements that ASR has? So, from a hypervisor point of view, ASR supports ESX and ESXi. It supports Hyper-V, Server 2012 R2, and Virtual Machine Manager 2012 R2. Now, with 2016 Server just coming out and System Center 2016 going GA, I expect support for those products will be announced really shortly. From a guest point of view, ASR only supports 64-bit operating systems. So even though in Azure we can run 32-bit guests, ASR only supports 64-bit guests. So that catches people out sometimes. But as you can see from the slides, there's good support for enterprise Linux guests as well. And it's only server operating systems that are supported, not client operating systems. Just a note, if you're running Oracle Enterprise Linux, I'm not a Linux man, so I need to check my notes here, and you're either running the Red Hat compatible or you need to be running the Red Hat compatible or unbreakable enterprise kernel for it to be supported by ASR. Now, we also have some Azure requirements that we need to be aware of. In Azure, the largest virtual machine we can deploy can have 64 data disks attached to it. So we've got an on-premises virtual machine with more than 64 data disks, 64 disks attached. We can't replicate that up to Azure. There's simply not a virtual machine big enough to be able to attach those disks to. But it's the second item on the slide that's probably the more important for people. In Azure, the largest data disk we can create is 1024 GB in size. That's a storage limitation. So we've got a virtual machine with a VMDK or a VHD file attached, which is larger than 1024 GB. We can't replicate it in its current state. What we need to do, and I've got a customer that's done this and it's worked really well, is we need to attach 2 smaller VHDs or VMDKs, create a stripe or a storage space, or the Linux equivalent, and we need to move our data onto those disks. And then we can replicate that virtual machine up to Azure. Okay? So there's ways to get around this. It's just a little bit of work we've got to do. Now, it's not just, obviously, the configuration of that virtual machine. We also need to make sure that the software we're running is supported in Azure. If you're running Microsoft Server workloads, Microsoft's got a handy website that has all of the information about the Microsoft Server workloads that are supported in Azure and the versions. But we don't just run Microsoft software, right? So we need to check with our software supplier. We'll check to make sure that the software is supported running in Azure. And we just want to double check any licensing requirements that we need to be aware of with the current licensing you have, just to make sure when you fail over to Azure, there's no implications that you're unaware of. we also need to consider capacity and the impact of replication on our host's storage and on the network bandwidth we have to Azure. Now, to help us figure this out, Microsoft have created a capacity planning tool that we can use. We select the scenario, in this case, Hyper-V to Azure. And then there's a bit of information that we need to enter in. Our data churn rate, which I'm going to come back to in a second, and the number of virtual machines we're going to fail over at any time, or we're going to replicate, and how quickly we want that replication to occur as well. And then what that's going to give us is going to give us an estimation of the amount of bandwidth that we need for our normal Delta replication, and the amount of bandwidth we're going to require for that initial replication as well. And also the amount of on-premises storage that we're going to require. Now, the reason for Hyper-V that we need on-premises storage is the replication technology is very similar to the snapshot technology. And when we do that initial replication, essentially all of our disk writes get written to the separate file. It's called an HRV file. And that can get quite large while we're replicating the virtual machine the first time. So we need to make sure we've got enough space to support that, just the same way you need to have enough space when you're doing snapshots. If you want to reduce the amount of bandwidth you require from a networking point of view, you can increase the amount of time that you're happy for that initial replication to occur. Now, to work out our data change rates, actually, quite often it's easier to go to your backup software and have a look, and that will give you an indication of how much your data is changing each day. But Microsoft do have a couple of tools that they recommend. So there's a vSphere replication capacity planning appliance that you can download. And these URLs, by the way, I'll make them available at the end on my blog so you can go there and grab them off. And there's also a site recovery capacity planning piece of software for Hyper-V as well that you can pull down, install, and it'll give you that indication. And this might sound really basic, but the other thing we need to consider is how our staff are going to access our virtual machines when we enact DR. Now, it could be that we enable point-to-site VPN connections. So we configure that on our staff laptops in a DR event. They fire up that VPN and they can access their virtual machines running in Azure that way. We might implement ExpressRoute and have multi-drops to different sites, and they access it via that mechanism. If our business applications are exposed to the internet normally, we can use Azure Traffic Manager to redirect our client connections to those virtual machines now running in Azure. I've also got a client who has installed an RDS gateway in their Azure subscription, and staff are taught that in a DR event, they go to that RDS gateway and they access their applications that way. And obviously with the Azure Citrix Express service, which has just been announced, which was going to be available early next year, that makes that scenario even easier still. So we just want to consider how we're going to get to those virtual machines when they're running in Azure. Okay, let's check in and see how that planned failover is going. Right, so our virtual machine failed across. It took about 3 minutes to orchestrate, and then a couple of minutes to start up. So about 5 minutes all up, which is pretty quick, really. Now, I'm not going to be able to log into this virtual machine just yet, and I wanted to show you the scenario specifically, because it catches people out, and it's something that comes up in the forums quite a bit. Because this is a standalone virtual machine, it's come up in Azure, it's got a new network adapter, and what's Windows Firewall done? It's locked itself back down again. So I can't RDP to this virtual machine at the moment because it's back in its protected mode. But because I installed the Azure VM agent, I can connect to that virtual machine via the control plane, and I can reset its RDP configuration. And it's really easy. If I scroll down, and I go to my reset password, but rather than resetting my password, I'm going to go reset configuration. So what that's going to do, it's going to kick off a job that's going to connect to the Azure VM agent, it's going to reset the RDP configuration, and allow me to be able to RDP back into this virtual machine. So it's just something that catches people out all the time. Okay, so that's going to take a minute or two to complete. So while it's doing that, let's pop back to the deck. No, because if you've got domain controllers in that VNet, then you won't have that scenario. So it's something to be aware of. And towards the end, I'm going to talk about Azure automation and how we can solve that automatically as well. But it's especially when you're doing a test failover, it just sort of catches people out. Oh, I can't log into my virtual machine. What's going on?
So you're saying if you had DCs and there were policies,
That's right, because it will see the DC, it will go, I'm in domain mode, sweet as, we're all good. Okay, so setting up Azure Site Recovery. I want to go over this pretty quickly because I actually want to show you it in the console, but I just want to give you the general feel. So the way we set up ASR, as I kind of hinted at, is different depending on the on-premises infrastructure that we've got. For the demo that we're running today, I've got a Hyper-V host, and I don't have Virtual Machine Manager. So I'm going to be prompted to create a site within ASR, and then I'm going to be prompted to deploy agents to my Hyper-V hosts and associate those hosts with that site. There's a config file I'm going to download, which is going to give all the information for my host to be able to go and register itself with that site. I'm then going to be prompted to create policies. These are my replication policies. I can have multiple policies per site, and those policies, as we'll see, I can control how frequent my replication occurs and when my replication occurs as well. Once I've done that, I can then associate my virtual machines with that site, and I can assign a replication policy to those virtual machines. If the replication policy is set to replicate immediately, they'll start protecting themselves up to Azure. So let's jump back across, see if our job's completed, and we can RDP into that virtual machine. So I've got a jump host that I've got running in Azure. And if I double click on this one, go connect. Ooh. Demo gods might not be with us today. Let's just double click our virtual machines. Test VM2. So our RDP's reset successfully. Let's just check the IP address that we've got. 100.6. Well, one more try. .6. I think you're right, yes. Thank you. So let's just go 192.168.100.6. No. Oh, look, something's obviously gone wrong. But like every good presenter, here's one I prepared earlier. Now this one will take a second to log in because it's a little bit of a smaller virtual machine. And although it's not quite the same, there is a marker file on here and it doesn't have the same random string of numbers that I attached to it as I had on the other one. So there it is there. But you get the general concept. Well, it's interesting to have a look afterwards to see what's gone slightly wrong with that virtual machine. All right, let's flick back across and have a look at setting up ASR. So if we go back across to our Recovery Services Vault, so I said our Recovery Services Vault shows us information about our Azure backups and our Azure Site Recovery. If we go down here, we can see the replicated items we've got, our recovery plans, the jobs that we're running. When I click into All Settings, we've got our Getting Started, which I'm going to take you through in a second. I just want to scroll down and go to our Site Recovery Infrastructure. Now, you might be tempted to go straight to the Site Recovery Infrastructure and go, hey, look, I can go in here, I can configure this all up. And absolutely, it gives us the information for each of the different scenarios that ASR supports. But what I'd recommend is when you're setting this up for the first time, go into the Getting Started and step through the, Microsoft call it a journey planner. It's a funny name for it. I think it's just a wizard, really. That prompts us and it provides us with just the information that we need for the scenario that we're working with. We're not having to sort through and try and figure out what software we need to download. So if I go into preparing my infrastructure, the first thing it asks me is, what do I want to do? All right, well, I want to replicate my virtual machines to Azure. I'm going to use Hyper-V, and I'm not using Virtual Machine Manager. So I click OK on that, and then all of the rest of this wizard is now going to just prompt me for those particular configuration and the software I need just for my scenario. I've already created a Hyper-V site, so I've got it there, and I've got my server attached. If I want to add another Hyper-V server, I just click on Add Server, and again, I just get the download for the agent I need for that scenario. I get the URLs that I need to put into my proxy server for it to work if I want to use my proxy. And I need to download the registration file for that Hyper-V, for the Hyper-V site that I've created. Once I've downloaded that, I've downloaded the agent, I install the agent, I pass it the file, it then registers itself. Can take 10 to 30 minutes. It'll appear here on my list. So once I've added the servers, I then need to prepare my target. So we need to tell ASR the Azure subscription that we want to deploy or store our virtual machines in. I talked about Resource Manager versus Classic before we started. Unless you've got a really good reason to use Classic, always use Resource Manager. It's the way Microsoft's going with these things. I've got my storage accounts already created, but I could go here to add a storage account. And I've got my network created as well. I could go here to add a network. So once I've got that set up, I then have my policies. So if I go to create a new policy, I need to give it a name, but more importantly, for Hyper-V, I can choose to replicate my virtual machines every 30 seconds, 5 minutes, or 15 minutes. I can choose how long I want to keep my recovery points for. The longer I keep my recovery points for, the more storage I consume in Azure, the more cost, right? So think about the RTOs and RPOs of your application and set that time frame based on that. I can also control how often I want to take application consistent snapshots using the VSS writer. If I don't want to take those, I can set 0 and I won't take any. And it's this bottom one I quite like. When do I want my initial replication to occur? Immediately, or I can set a time. Now, that time is based on the local time of my Hyper-V host. So I can have a policy that says I want to start replicating every 30 seconds, but actually I don't want to impact my production systems. So whenever I add a new virtual machine to that policy, I don't want my initial replication to occur until after 9 o'clock at night. So I can set that in the policy, and that way I'm not going to impact my production workloads. I can also configure throttling on my Hyper-V agent. So during business hours, it won't consume all of my network bandwidth available. So I can be smart about it. Close that. So once I've set my replication policies, it's at this point that it prompts and says, hey, have you done your capacity planning? I kind of think it should have prompted us a little bit earlier in the process, but I guess we're kind of invested in it at this point, right? But it's important to know that you can download the capacity planning tool from here if you need to get it. So I'm not going to OK that because we've already got that running. The next step is to replicate our applications. So we configure our source, in this case it's the ASR Hyper-V site that we created. And then we need to give it a bit of information again about the subscription that we want to recover our virtual machines to. So we can have a separate subscription that we store our DR copies in to the subscription that we actually fail over to and create our virtual machines in. We get that choice of classic versus resource manager, the storage account that we want to run our virtual machines in, and the network that we want to place them into as well. Once we've done that, then we can select the virtual machines. Now, all of my virtual machines are currently selected, but we'd see them here on the list. After we select a virtual machine, we then need to configure the size of the virtual machine in Azure that we want to spin up, and we assign it a replication policy. And a virtual machine can only have one replication policy associated to it at a time. So it's really easy to set up. The other thing I want to show you quickly, before we go back to the slides, is under monitoring and reports, if we go into alerts and events and go into site recovery, we can see here all of our warnings and information. And you can tell I've been doing a bit of a practice, which is probably why I managed to break that virtual machine. But what I wanted to point out was under email notification, this isn't enabled by default. So I recommend to anybody which is using ASR, come in and turn the email notifications on. Now you can choose to have email sent to all of your subscription admins, but I actually prefer to specifically set the administrators that are looking after ASR. And they'll get a set of emails if there's any issues. And sometimes, replication can be a bit delayed, so your replication state will transition to a warning state, and then it'll come back healthy again. Or if you're doing failovers like I am, you can get those alerts. So it's really important to turn it on so that you actually get that information as well as coming into the console to be sort of checking in to see how things are going. And ASR is one of those technologies that once you've set it up, it just kind of ticks along in the background. And sometimes people forget to go in and check to make sure everything's, tickety-boo. Okay, so we'll just close back down there and we'll go to test VM2. How we go for time? Right, let's flick back across to the slides. Okay, so it's really easy to set up ASR, right? But what about actually failing over and failing back from Azure? Surely that's got to be difficult. It's got to be difficult somewhere. Well, it's not, but there are a number of steps that we need to go through, and I just want to wind back. Even though we kicked off a planned failover at the start of this session, I just want to wind back to the very beginning and sort of talk about failover in a bit more detail. And the first thing that I want to make sure everybody's aware of is failover doesn't occur automatically. We have to go into the ASR console, either via PowerShell or going into the Azure portal, and we have to tell ASR we want to fail over. There's no timers we can set. There's no poll my virtual machine, and if I can't see you after 5 minutes, I'm going to trigger a failover. We have to go in and kick it off. Now, Microsoft have released a software development kit, so we can use that software development kit to integrate it into our monitoring platform and have our monitoring platform programmatically trigger a failover. But it's, sometimes people install it and they go, where's the polling to get my DR to enact automatically? It doesn't do that, it's not designed that way. So we have to initiate this failover. There are 3 types of failover that we can initiate. The first type is a test failover. Okay? So with this option, our current replication is not impacted in any way. A copy of our virtual machine is brought up. Now, we should do this into a test VNet. You can choose your production VNet. It's a really bad idea to have 2 copies of the same virtual machine talking to the same AD, right? Okay, so buyer beware, just be a bit warned. Have a test VNet, choose that, bring up the virtual machine. You can log in, you can check it to make sure everything's running as you expect. And then when you're finished, you tell ASR, yep, I'm all done. And it will remove that virtual machine for you and clean up. Okay? The next option we've got is the planned failover. This is what I kicked off at the start of this session. Now, we do a planned failover if we've got on-premise maintenance, which is coming up, and we want to evacuate those virtual machines up to Azure before that maintenance. When we kick off a planned failover, ASR shuts down our on-premises virtual machines, and it performs a final delta replication. Now, it does that so we have no data loss. Once that delta replication is completed, it brings our virtual machines online in Azure. The final option we have is an unplanned failover. Now, we might have to enact this because of administrator misadventure, and we've broken a virtual machine, or we could have a whole site that's gone down. The really important thing to understand with an unplanned failover is that delta replication does not occur. ASR assumes that our on-premises virtual machines are non-viable, and it starts up our virtual machines in Azure using the last recovery point that it has. So if we've got 15-minute replication, we could have 15 minutes worth of data loss. So we need to look at our RPOs and RTOs and just be aware of those implications. Okay, so once we've failed over and our virtual machines are running in Azure, there's a couple of things that we can do. We need to log into our virtual machines just to check to make sure they're running as we expect. If we've made a manual change, there's a chance that that change may have been replicated up to Azure. And we might want to roll our virtual machine back to a previous recovery point. So we can do that by selecting the Change PIT option. It'll present all of the recovery points available to us. We can select an earlier recovery point, and then it will roll the machine back to that recovery point. If we're happy with the way the virtual machine is running, then we can choose Commit. When we choose Commit, the snapshots that ASR has created to enable the rollback get removed, and the machine gets prepped for fail back to on-premises. The other option that we get is to complete migration. Now, complete migration is there because some people can use ASR to migrate to Azure and stay in Azure. It actually works really well for that scenario. So what complete migration does, it's a one-way road, right? It does a commit, and then it removes that virtual machine from ASR. It cleans up all of the configuration. So according to ASR, that virtual machine doesn't exist anymore. So if you're wanting to migrate to Azure, that's an awesome option to click on. If you've got any aspiration of failing back once you've rebuilt your on-premises or done whatever you need to do, that's not the option to choose because you won't be able to fail back if you select that one. So let's jump back onto that VM2. Let's do a complete that migration, and then we'll see what options we get in terms of failing back. So I've got VM2 here, and we're going to click on Commit. And yep, we want to commit that failover. And if we go in here, we can see that job running. And we can see that that commit occurs really quickly. So go back to test VM2. So the next set of options we get is we can do a planned failover, fail our virtual machine back to on-premises, or we still get that option to complete migration. Microsoft are keen for us to leave it running in Azure, costing money. So we're going to click on planned failover. Okay, ASR knows what we're doing. It knows we've failed across. So it's going, all right, cool. So you want to fail back from Azure to on-premises. We get two options. If we've been running in DR for less than 24 hours, then Microsoft recommend choosing minimize downtime. And what it's going to do is it's going to synchronize the changes that have occurred in Azure with our on-premises infrastructure and just copy across those changes. If we've been running for longer than 24 hours, then Microsoft recommend that we choose full download. Full download will have a larger outage window because we have to shut down our virtual machine and copy the VHD back to on-premise. No, we've only been running for a couple of minutes, so we're going to choose minimize downtime. And we'll click in, and we'll see this job. There's a number of steps that it's going to go through. And with the synchronize failback, once it's synchronized up our Azure and on-premises, it's going to need to shut down our Azure virtual machine to do that final Delta replication. That's going to cause a production outage. So what it actually does is the job's going to pause and wait for user input. So we can trigger this failback off during the day. Once it's synchronized, it's going to sit there. And then when we hit our change window that night, we can come in and we can go complete and continue. And at that point, it's going to shut down our Azure virtual machine. It's going to do our Delta replication. And it's going to bring our virtual machines back up on premises. So it's quite smart about that, and it's quite an easy process to go through. So let's flick back to our slides. So we're now running back on premises. We've checked our virtual machines. We've still got data disks sitting there in Azure in case we need them. Our virtual machines are fine. We're happy with the way everything's running. We then go and choose commit. When we choose commit, ASR cleans up those data disks that are sitting there in Azure and gets us ready to go back into our production state. There's one final step that we need to take. We need to reverse our replication. Now, the reason we need to do this, as the product group have sort of told me, is that when we're doing a large fail back, as virtual machines come back up on premise, we don't necessarily want that replication traffic going back to Azure, impacting our traffic, our replication traffic coming down. So what happens is our replication back to Azure doesn't start occurring until we're ready, all of our virtual machines are staged, we're happy that they're running, and then we reverse that replication. And our virtual machines start protecting themselves back to Azure. Now, it's the only option you can choose in the console, but it's important you understand that you need to perform that step, because what I've seen occur is people go, yep, I've committed my failback, I'm all good, I'm running back on premises, but I haven't reversed my replication. So my virtual machines aren't protecting themselves back to Azure at that point. I'm running in an unprotected state. So you need to remember to go in and complete that final step. It's really obvious once you get into the console, because you see that you can't do anything else. You can't fail back to Azure until you've reversed that replication. Okay, so it's an important thing to know. Okay, so we've looked at a single VM, but what about if we want to orchestrate the failing over of a number of virtual machines? This is where recovery plans come into play. With recovery plans, we can add multiple virtual machines into this recovery plan, and we can treat these virtual machines as a single item. So we can perform that test failover, planned failover, unplanned failover on that group of virtual machines. But it's a bit smarter than that. We can have multiple groups within a recovery plan, and we can control which order those groups are failed over in. So if we've got dependencies, we can order that recovery plan so that we meet those dependencies, so that when we bring our application up, it's actually going to see the database and the file server and whatever else that we need. We can also have pre and post tasks which occur against those virtual machines to help orchestrate that failover. Now those tasks can either be manual tasks that we put into the recovery plan, and it will pause at that point and it will prompt our staff member to say, hey, you need to do this, let me know when you've done that and I'll go on to the next step. Or they can be automatic tasks using Azure Automation, and this is where Azure Automation becomes really powerful to do that automatically for us. And then once those tasks have completed, it'll then move on to the next set of servers, the next group of servers. So how many people in the audience have actually used Azure Automation? One, couple, a few brave souls. Right, I could spend a whole session talking about Azure Automation, but the key thing to understand is that Azure Automation, it allows us to run scripts against our Azure resources and essentially reconfigure those Azure resources programmatically. To make it even easier when using Azure Automation with recovery plans, Microsoft have created what they call an Azure Automation context. Now, this is essentially an object that our recovery plan passes to our Azure Automation runbook, and it has a whole lot of information in it about the virtual machines it's just created. And this is the whole chicken and egg thing. My runbook needs to be told a virtual machine ID to go and attach to, but I don't know my virtual machine ID until I've created it in a failover situation. Okay, so this Azure Automation runbook, this is the bit that solves that problem for us because it has the VM map key in there. So it gets passed to our runbook can read the VM map key, and then it knows the virtual machines that it needs to go and actually reconfigure. And it's really powerful. I can use it to add virtual machines to external or internal load balancers. I can update network security groups. I can reset my RDP configuration using Azure Automation. I can even use Azure Automation to run local scripts inside my virtual machines. Got to have the VM agent installed. So I can do that, say, if I want to reconfigure my DNS, when I fail over to Azure, I might have a different DNS server I need to talk to. I can run a script to change that. I might need to reconfigure my application to point to slightly different places. Azure Automation is the key here to be able to do that. So let's jump in and have a quick look at recovery plans, keeping an eye on time. So if we scroll down here under recovery plans, so I've got one I created earlier. Now, there's a couple of things just to be aware of, and it caught me out the first time I was playing around in this. Normally, in the portal with the blades, you click on all settings, and you get all of the configuration settings, and that's where you go and update everything. But as you can see, all settings is pretty empty. You actually need to click up the top here and click Customize, and that's where you go and customize your recovery plan. So they haven't quite followed the standards that have been set with some of the other blades. You can see, as I talked about, we can do our test failover, planned failover. We can't complete a migration using a recovery plan. That is a per VM setting. So in our recovery plan, we've got our different groups here. So I've got test VM3 set to come up first. And I've got a post step here, which is a manual action to check RDP. If I go into that and go update that action, so you can see we have a name, We have instructions that will be displayed when we run this recovery plan. And we can also select which scenarios we want this step to be executed under. So we might have an Azure automation job, but actually when we're doing a test failover, we don't want that job to run because it's going to update a production system, which is then going to cause us bigger problems. To add an automatic task, if we click in here, and we'll go add a post action. This is where we get the option of doing that script or that manual action. Give it a name, we choose our automation account, and then we select the runbook that we want to add. So we can't update the runbooks from within ASR. We can just select the runbooks that we've published within our automation account. And we can see here I've got this runbook running the script within the VM. So it's really easy to be able to go in and add these runbooks and orchestrate that failover, and also reach outside of the virtual machines we're failing over to those external applications that need to be able to communicate with those virtual machines and reconfigure them, fully orchestrate that failover. Right, let's jump back to the slides just to finish off. So I've got a couple of links here. The first one is troubleshooting, and it's a really good URL to have a look at if you're looking at using ASR, because it has a whole lot of hints and tips around how you troubleshoot it. And the second one there is a set of FAQs with a whole lot of questions and answers that people have put forward to the product group. And that's got some really good resources in it as well, which will help you getting started. But just to sort of recap. So in the session, I've shown you how with a bit of planning, we can use ASR to protect our on-premise workloads to Azure. We can run them in Azure in a DR situation. And when we've recovered from that DR situation, we can replicate them back to our on-premises infrastructure. So they're not stuck in Azure forever. And if there's one thing that I want you to take away from this session today, it's this, that Azure Site Recovery makes DR easy and affordable. And my call to action for you is when Igniter's all done and dusted and you're back next week and you've got over your hangover from Thursday night, that have a look at your current DR strategy and consider how ASR could enhance it. Now, for those of you that want to get hold of those URLs that I put through the slide deck, if you go to my blog under Presentations, ASR, I've got all of the URLs sitting there so you can grab those out and have a read at your leisure. Hey, look, thank you so much for coming to the session today. Sorry, go back if you want. I do really appreciate it. Please fill out your evaluation forms. I do value your feedback, and you can go in the draw to win some great prizes. How are we going for time? We've got about 5 minutes. For those of you that want to get a head start on the next session, please feel free to nip away. And those of you that have questions, maybe you want to come up the front, and I'll just start packing up and answer those questions. Hey, thank you so much.